A figure in the plane has rotational symmetry, or radial symmetry, if the figure can be mapped onto itself by being rotated less than 360 degrees clockwise or counterclockwise about the center of the figure, so the image and the pre-image are indistinguishable. The point in which a figure can be rotated onto itself is called the center of symmetry. Sometimes you will hear this referred to as point of symmetry. This figure, when it's rotated, has rotational symmetry because a rotation of 90 degrees, 180 degrees, or 270 degrees maps the figure onto itself. The number of times that a figure maps onto itself as it rotates from 0 degrees to 360 degrees is called the order of symmetry. The magnitude of symmetry, sometimes you'll hear this referred to as the angle of rotation, is the smallest angle through which a figure can be rotated so that it maps onto itself. The order and the magnitude of rotation are related by the following equation. Magnitude is equal to 360 degrees divided by the order. This figure has order 4 and magnitude 90 degrees, so this figure can map onto itself with a composition of rotations clockwise or counterclockwise if each angle of rotation is a multiple of the magnitude or a multiple of 90 degrees. Point symmetry. A figure has point symmetry if it can be mapped onto itself by a rotation of 180 degrees, like we're about to see in this picture. If a figure has point symmetry, then the center of symmetry in the figure is called the point of symmetry. In this example, a rhombus has point symmetry because it looks the same right side up as upside down. Objects found in nature often have rotational symmetry. Determine whether each figure has rotational symmetry. Explain. So in this first figure, we have a leaf. If we were to rotate this leaf some degree measure less than 360, and it looks like this exact leaf, then it has rotational symmetry. So let's go ahead and rotate it and see if this figure has rotational symmetry. So the only time that this leaf looked like the original is when it rotated a full 360 degrees. So this leaf does not have rotational symmetry. Let's look at figure B. It is a flower that has 8 petals, and the petals appear to be the exact same. So let's rotate it and see what happens. Yes, if you rotate it less than 360 degrees, it will map onto itself. Now, because this has rotational symmetry, let's count how many turns it takes for the blue dot on our petal to get back to the blue dot that is above the flower. 1, 2, 3, 4, 5, 6, 7, 8. It took 8 turns to get back to its original petal. So that means that this flower has rotational symmetry and its order is 8. To determine the magnitude, you take 360 and divide it by 8. 360 divided by 8 is 45. Let's look at this 4-leaf clover and rotate it to see if it has rotational symmetry. It does have rotational symmetry. Let's count how many turns it takes for that blue dot to get back to its original position. 1, 2, 3, 4. So this four-leaf clover has rotational symmetry, its order is 4, and in order to find its magnitude, we take 360 and divide it by 4, which is 90 degrees. Check. Below are several objects that you might find around the house. Determine whether each figure has rotational symmetry and explain. Teachers, please pause the video now. So this first object has rotational symmetry because you can rotate it a degree measure less than 360. This one was similar to our flower, so it's actually 45 degrees. So you can rotate it 45 degrees and it will map back onto itself. So it has rotational symmetry. The scissors do not have rotational symmetry because you cannot rotate them any degree measure less than 360 and the object will appear the same as the original. A tablet can map onto itself after a degree rotation of 180 degrees. So it does have rotational symmetry. Part A. State the order and magnitude of symmetry. Determine whether each figure has rotational symmetry. If so, locate the center of symmetry and state the order and magnitude of symmetry. Part B. Identify point symmetry. Which figure or figures in Part A has point symmetry? Justify your reasoning. So first, let's see if these figures have rotational symmetry. So let's look at figure A. If we rotate it, is there a degree measure less than 360 where this pentagon will match up with itself? Hey, it does. And it took 5 turns to get back to the original orientation. So this figure has order 5. Let's look at B. When we turned it, there wasn't a time less than 360 degrees that it matched up with its original quadrilateral. So B does not have rotational symmetry. Let's look at C. So when we turned C 180 degrees, it did match up with the original. So it does have rotational symmetry. So in figure A, it does have rotational symmetry, and the center of the pentagon was the point of symmetry. So it does have rotational symmetry. It has order 5 because it took 5 turns to get back to the original point. Then the magnitude is 360 divided by 5, which is 72. As we saw in figure B, it did not have rotational symmetry, so it does not have order, nor does it have magnitude. In figure C, the center of symmetry, or the point of symmetry, is the point that is in the middle of that parallelogram. It does have rotational symmetry. Its order is 2, and its magnitude is 360 divided by 2, which is 180 degrees. For part B, identify point symmetry. Remember that point symmetry is when you have 180 degree rotational symmetry. So in these figures, A had rotational symmetry, but it did not have 180 degree rotational symmetry. B did not have rotational symmetry at all, so it cannot have point symmetry. But C, the parallelogram, had 180 degree rotational symmetry that it would map back onto itself. So figure C has point symmetry. Think about it. If a figure has line symmetry and rotational symmetry, what composition of transformations will map the figure onto itself? Teachers, please pause the video and have your students discuss. A possible answer might be, if a figure has line symmetry and rotational symmetry, then the figure will map onto itself with the following composition of transformations: a reflection in any line of symmetry, or a rotation about the center of a figure and through any angle that is a multiple of the magnitude.